Perfect. So, in this part of the course, we are going to practice soldering with tin. We will be talking about some details, some tips, so that you can solder in the best way without damaging components on boards and also without wasting time, so that you can do it in a practical and quick way. Well, we are going to use some component that is fixed on this board as a sample. Let's suppose we want to remove some of the resistors that are at these points. Let's take this one. This one seems like we had already taken it out, right? Let's take another one. Let's take out this resistor. So, let's say we have a resistor with an incorrect value and we have to replace it. So, what we are going to do is the following. We are going to apply heat, of course with the tin solder, but to remove any component, it is essential that you apply new tin at that point. It usually happens in most electronic boards that come completely varnished. So, when we try to reheat these points, it is difficult for the tin to melt. So, what do we have to do if it gets complicated in this part when melting the tin? We have to apply new tin. We are going to apply our tin, good and new, of good quality, at the point we want to desolder. We heat the area well and apply the tin. Well, we heat well and apply tin. Perfect. Now we are going to use our vacuum desoldering iron or tin sucker. Always with the solder iron well cleaned. And the solder iron can always be cleaned on some kind of sponge, vegetable, or similar. And we suck the tin. Well, this is how we are going to leave the area clean. The tin sucker is going to clean all the tin well for us. As you know, the tip will not overheat or be damaged because it is precisely made to withstand high temperatures. Well, once we do this, what we are going to do is lift the terminals of the component, which are bent so that the component stays more fixed. We will straighten them again. And almost at this point, we should be ready to take it out. Let's look from the other side. Yes, we already have the component almost out. It's this one. There it is, it came out without problems. This is thanks to the fact that we made a good suction of the tin. Remember to use good quality tools, such as the ones we recommend, to be able to solder and desolder in this way. Well, once we have done this, we are going to clean the area again and we are going to leave it well cleaned and correct to be able to put the new component back in. We will keep cleaning. And once we see that the tin sucker is not sucking anymore, we are going to apply the desoldering mesh. We are going to apply always, remember, the solder iron well cleaned. We heat the mesh and apply it over the area to be cleaned. Very well. And if we wanted to, we could apply isopropyl alcohol for a final cleaning in case it is necessary. I am going to apply it, just to be able to show it well. The area is now clean enough to replace the component. In this case, we would be replacing a new component, of course. But we are going to place the exact same one. So, to replace the resistor, we try to give the terminals the correct shape with some of the pliers we have. And so we have the correct shape. And we place it, of course. Now, what we are going to do is turn the board over and bend the wires so that it is fixed and held in place to be able to solder correctly. To be able to solder, it is important that it is well fixed, because if it moves at the moment of soldering, we run the risk of producing a cold solder. Look how it will look now when I solder it. We are going to heat it up well. The trick and key is to heat up the base and the component well. The base and the terminals of the component must be very hot. Very hot. And at that moment, we apply the new tin. And it has to look like this, a shiny drop of tin. Again, the same thing. We heat up the base and the component, apply tin, and it has to be very shiny. If the component is not well fixed before the moment of soldering, you may run the risk that the component will move just at the moment the tin cools down, and that can produce a cold solder. What does that mean? Well, you saw when we heated the iron, you put it red hot and the molecules expand, and then when it cools down, they come back together. What happens if we heat and cool down suddenly? If we cool down suddenly, the molecules lock up and the iron or steel is tempered. It is a process that is necessary to create tempered steel. If you heat it and cool it down quickly so that the molecules cross, so to speak, they lock up and become much harder. Only that it is no longer flexible. When we try to bend it, it breaks directly. Well, the same thing happens with tin. If when it is cooling down we move the area, the molecules cross and it may be that they do not produce, or it may be that they do not transmit electricity, that they do not allow the passage of electrons. That is why the area has to be well fixed. In this way, at the moment of cooling down, the molecules are arranged correctly and the tin is formed visually when the solder points are shiny. If they are shiny, it is correct. If they are very opaque, do everything again. The key is to heat up the base plate and the component well, and then apply the tin. And, of course, that the component is fixed before soldering. This also applies to copper welding. If you, as refrigeration technicians, weld with copper, remember that the key to all these soft solders is to apply heat first to the equipment parts, and finally apply the soft material that will be welded. That is the key. Heat the areas well that we need to solder, and, at the end, there is the copper rod, the Harris rod, the tin in this case, and that is how it has to be. Something else you can do is apply silicone. Remember that these areas are well varnished because the air conditioning unit is always exposed to dust and moisture. So if you can apply silicone, let's see if I have the gun turned on. No, it's off. The ideal is to apply silicone to be able to cover and so that it is not exposed to dust and moisture and that a short circuit may occur. Just as it is in this case that we made a jumper, or here that we also made a jumper that we will now do in a moment. Or here that we have also replaced a resistor. In a moment we will apply silicone here. Remember, the silicone has to be. This has to be the heated silicone gun, because this is the silicone that can be applied in electronics. We will apply it here, and when making a jumper we will also apply it to protect the area so that it remains isolated. Very well. We will let it heat up. it was turned off. That's why it's cold and it's heating up slowly. Well, in the meantime, I'll show you how components come when they're new. When you buy resistors or diodes, they come this way. When you buy these components, they come with long wires that give us the possibility of molding them as we need and being able to adapt them or fix them to the board in the position we want. They are very flexible wires that give that possibility. And once you place these components on the other side, if we place it in any of these points, let's see. Let's say we'll place it here. And it's too long. Well, we're going to bend it to be able to fix it to the side where the track continues. Be careful, don't bend it to the other side that could make contact with another point. Bend it to the side where the track continues. Let it be well fixed. Make the weld. Make the weld at this point. We heat it well, apply tin. We make the weld. Let's do it again so it can be understood well. Bend it to the side where the track continues. If we leave it well fixed, we heat it, we produce the weld. And finally, what we are going to do is cut off the remaining wire. Cut off the remaining wire. And then we have the component well fixed. This is as a sample. I only did it as a sample, using a new diode and soldering anywhere on the board. Remember that you have to cut off the excess wire. And that's how it has to be. It has to be well neat and fixed. Well, we go back to the silicone gun and we're going to cover the area. Perfect. And we're going to cover the other resistor that we soldered a moment ago, which is this one. Well, we can apply this silicone without fear because it does not conduct electricity. So then, we have the contacts well covered and they will no longer conduct electricity. Of course, they will not consume electricity if another component touches them here. But they, of course, continue to conduct the electricity from the component to the entire track. Very well, that's how we're going to solder with tin. This is the correct way to use the tin solder and to do it quickly and efficiently. Please leave a comment if you have any questions.